In today's lesson, we're having a look at reduction formula. Now we use reduction formula to write trigonometric functions in terms of acute angles. Now I feel this is quite an important lesson to do because we do not want to confuse reduction formula with compound identities. Now let's have a look what I mean. Here we are given the cosine of 360 degrees minus theta. And for some of us, we would immediately think that this is a compound identity and we will write it out as a cosine compound identity, right? But here we do not have to because I can identify that this is a reduction formula. Now, how do I know this? Because one of these two angles is a critical point on our Cartesian plane. Now, if we have a look, 0 degrees, 360 degrees, 90 degrees, 180 degrees, and 270 degrees is our critical points on the Cartesian plane. So when one of these angles are one of those critical points, well, then we can just apply reduction formula and write this in terms of the acute angle. Now let's see how we will do this. Now before we can start, we need to revisit our Cartesian plane. And I'm going to start here in the first quadrant. As you can see, here is the letter A. Now that means that all our functions, well, the cosine, the sine, and the tangent function are all positive. In the second quadrant, there's an S. Only our sine function is positive. The other two are negative. Here in the third quadrant, only our tangent is positive and the other two negative. In the fourth quadrant, we've got C for the cosine and only the cosine function is positive. So we can remember it easily as cast, and therefore we can use this information to help us rewrite this in terms of the acute angle. Now let's go and see. We start with the critical point and it's a positive 360, okay? So 360 is here, and because it's a positive value, we go anti-clockwise. So there we go, and we pass 90, 180, 270, and we get back to 360. But then there's a minus an acute angle. So minus is clockwise. So we go back this way. And as you can see, we're in the fourth quadrant. Now, after we identified our quadrant, we go and see what we are busy with. We're busy with the cosine. We're in the fourth quadrant. In the fourth quadrant, our cosine is positive. So we write the positive sign, then we write the cosine, and then we just write the acute angle. And there we go. Let's have a look at another example. The sine 360 degrees minus theta is equal to, and let's quickly have a look. So again, we go 360 degrees and then minus theta. We're in the fourth quadrant and we are busy with sine, but in the fourth quadrant, sine is negative. So we write the negative value, then we write sine and we write the acute angle, and there we're done. Now the third one, we've got the tangent of 180 degrees plus theta. So again, we start at 0, we go 180 degrees. So there we go, and then we plus theta, and we end up in the third quadrant. Now we're busy with the tangent. In the third quadrant, tangent is positive. So we write the positive sign, then we write the tangent down, and we write the acute angle next to it. There we go. Now one more example. Here we have the cosine of theta minus 180 degrees, and let's quickly see what we're going to do now. Well, we start with our critical point, but it's a minus 180 degrees. So because it's a negative 180, we go clockwise. So we start at 0 and we go 180 degrees clockwise. There we go. And then this is a positive theta, so we go anti-clockwise and we end up in the third quadrant. We're busy with the cosine. In the third quadrant, cosine is negative, so we write the negative sign, then we write the cosine down and with the acute angle next to it, and there we go. Now we're going to go and have a look at what do we do if we have certain functions that contains the 90 and the 270 degrees. Now in this part of the lesson, we're going to have a look at what happens to a cosine and a sine function when we are using 90 degrees and 270 degrees. Just so you know, you will never see a tangent function with 270 and 90 degrees because they do not exist there. So here we go. Now cosine 90 degrees minus theta. We know this is reduction formula because here we have a critical point and it's positive. So we start at 0, then we go 90 degrees, and then that means anti-clockwise, then minus theta, that is clockwise, and we end up in quadrant 1. Now please follow the steps. Now that we know in which quadrant we are, we go and look at the function that was given. The cosine in the first quadrant is positive, so we write the positive sign. Then we change the cosine to a sine function and we write the acute angle. Got it? Now next one, cosine 90 degrees plus theta. So again, what do? We go to 0 and we go 90 degrees anti-clockwise. Then we've got plus an acute angle, so again it is anti-clockwise, and we end up in the second quadrant. Now that we know where we are, we look at the function that is given. In the second quadrant, the cosine is negative, so we write a minus, and then we change the cosine to a sine, and then we write the acute angle. Got it? Okay, third example, sine 90 degrees plus theta. So here we go. We go back to the 0 degrees, then we go 90 anti-clockwise plus theta, that is again anti-clockwise, and we end up in the second quadrant. Now we are given a sign. In the second quadrant, the sign is positive, so we write the positive sign, and then we change the sine function to a cosine function, and we write the acute angle. There we go. And then the next example, we've got sine theta minus 90 degrees. So because we have a minus 90, we start at 0 and we go clockwise. And there we go. And then we've got a positive acute angle. So again, we go anti-clockwise and we end up in the fourth quadrant. Now in this fourth quadrant, the sign that we are given is negative, so we write the minus, then we change the sign to a cosine and we write the acute angle. Got it? Now, next one, sine 270 degrees plus theta. Now we start at 0, we go around 270 degrees, there we go, plus an acute angle, and we end up in the fourth quadrant. Now, we are given a sign. In the fourth quadrant, sign is negative. So we write the negative value or the sign minus, and then we change the sine function to a cosine function and we write the acute angle. Got it? Now, last example. That's when we're given the sine function of these two values, but one of the angles is a very large angle. Now what we simply do is we try not to think about this as 3 revolutions. We are going to rewrite this as just 1, because it doesn't matter if I go around 3 times and I end here, or just 1 time and I end there. So that makes it a bit easier. So what we do is we take this large value and we keep subtracting 360 until we get to a value that is 360 degrees or smaller. So 1080 degrees minus 360 is 720. 720 minus 360 is 360. Okay, so we want 360 or smaller. So we got 360. So we can just rewrite it as this. And now it's a normal reduction formula. We go around 360, there we go, plus theta, and we end up in the first quadrant. Now sine in the first quadrant is positive. It's 360, so we don't have to change the sine to a cosine. It stays a sine, and we write the acute angle. Very well. Okay, so I hope you could follow, and see you again next time. Bye.